All right, good afternoon, everybody. So my name is Otto, and I'm going to be talking about scalable web front-end development in Scala. Now, I must confess that I've never used Clojure myself. I blame it on the university courses using Scheme that sort of killed my interest in these kind of Lisp-like languages. But fortunately, there are other alternatives out there. So are there a lot of Scala developers in the audience? Well, quite a few. Any of you used Scala.js? So there's a lot of new souls to be evangelized on. All right, before we begin with the actual content, just a couple of words of myself. So I'm working for a company called Umbra. We do graphics optimization technology for game developers, architects, and industrial designers. Our solution is running in the cloud. It's kind of an unholy alliance between C++ and Scala code, where we optimize these complex 3D models so that you can actually run them on limited devices like HoloLens, as displayed here, or other mobile devices. Umbra is growing rapidly, and we are hiring developers, both Scala and graphics programmers, in our Helsinki and Tampere offices. But during the night, I also program in Scala, but I'm doing it in the open source context. So I work on multiple different open source libraries, and also things like scalafiddle.io, which is an online playground where you can try out Scala. It actually compiles your Scala to JavaScript, so you can run your code in your own browser. You can share whatever you've done. It works pretty much similar to JS Fiddle and these other solutions. But back to the stuff that I'm going to be talking about. So front-end development, it's been done in JavaScript for ages, so why not just keep using JavaScript? Well, as we all know, there are a lot of reasons why you shouldn't be using JavaScript, including your mental health. But the main reason really is that the complexity of front-end application just keeps growing. It started very simple. Back in the day, everything was done on the server side, rendering HTML from PHP and other great languages. And you might have something like jQuery to do little things, little interactions, animations in the browser itself. But then at some point, people started thinking that, okay, maybe we can do more on the front-end side. And with libraries like Angular, you would actually move a lot of that responsibility from the server to the front end. So you would have the HTML templates inside your front-end application, and the server is sort of reduced to an API that provides like a REST API, so you can access the data and do updates. But over time, people realized that the Angular approach is not scalable enough. You could end up pretty confusing code. So new libraries like React came up with an even more sort of, let's say, restrictive or constrained model that how you should do these front-end applications. So these frameworks and libraries kept evolving, but at some point, as the complexity keeps growing all the time, even the language itself, JavaScript itself, became the bottleneck. So nowadays, a lot of people are using different solutions like TypeScript, Elm, ClojureScript, and Scala.js to do these applications. Now you might think that, okay, doing things in JavaScript is easy, it's simple, but if we look at like a typical example of a React boilerplate, so like a beginner startup project that you would use to start a React application, you find out that this simple boilerplate has over 80 dependencies just to get something started on your React application. So it's not that simple anymore. Building a large-scale application in JavaScript is like building a house of cards. You have to be very careful, and in the end, when you do refactoring and changes, you might end up messing things pretty badly, even if you are like an experienced programmer. Now imagine when you give JavaScript to more junior developers, it doesn't really end up so great. It feels great to do stuff in JavaScript, but it really ends up in a mess. So why Scala.js out of all these other options? To understand Scala.js, we must, of course, first understand Scala, the language underneath Scala.js. So Scala is a modern multi-paradigm language with very strong typing. It allows you to program in the style you want, whether it's object-oriented if you're coming from Java, or functional if you prefer things like Haskell or Clojure. So regardless of your background, you can get started pretty easily, whether you are coming from JavaScript or Java or even PHP. Of course, for some people, purity is the number one thing, is the essence that they really want to have really pure code. For them, there are other options out there. So what does Scala look like? This is a slide I've been using for a couple of years now, mostly in JavaScript talks and so on. So this is Scala. It looks like JavaScript in this case. The only thing that sort of separates it from JavaScript is that one type definition for event there. So if you're coming from JavaScript and want to start trying Scala.js, it's relatively easy to start writing Scala because you can do it in a very JavaScript way. But over time, you want to get more advanced. So if you like category theory and functional programming, you can also do that in Scala. So you get all these four comprehensions and monads and monad transformations and composition and all the stuff that you can as well use. It's quite typical that when you start doing Scala, you begin with something that you know that you start writing Scala, like it's Java or JavaScript. Over time, you learn the benefits of functional programming, immutability, why it makes your code more robust, and the benefits of strong typing. Because as we say in Scala, if it compiles, it works, and that's surprisingly often quite true. And then you get to really enjoy the benefit of Scala. So in my opinion, Scala is great for like practical programmers who don't have like a strong ideology that, okay, this is the only way how to do things, but who just want to get stuff done and learn new things over time. Now Scala.js is just simply, it's a compiler plugin for Scala that instead of outputting JVM bytecode, it outputs optimized JavaScript. It's been stable and production ready for a couple of years already. Just today they launched 0.6.20, so that's like 20 backwards compatible versions of Scala.js over the 3 years. 1.0 version is coming over the few weeks, but there are no really big changes. Just some breaking changes that sort of make it reasonable to update the version number. Scala.js offers a great developer experience because it's underneath, it's just Scala, so you can use all the IDE, all the other tools that exist there. It gives you an isomorphic environment, so you can write Scala both on the back end and on the front end. So you can share code, you can share data models. If you change those models, the compiler sort of makes sure that both the code on the server and the front end side stay in sync, so you don't make any surprising mistakes. It has the best-in-class JavaScript interoperability, so if you want to use some JavaScript libraries, it's very easy to use them. You can also expose Scala code to JavaScript back and forth, so it really works very well. A lot of existing Scala libraries have been ported to Scala.js. Typically, it's just a configuration thing in the build, unless you have like Java dependencies. And the ecosystem is really great. The documentation is good. There's a lot of examples, a lot of code out there that you can look into. And also we have very active chat room for Scala.js. So typically when you start with Scala.js, you usually use some kind of framework to get things done. I think most popular one is the Scala.js React, which is simply a wrapper around the Facebook React.js library. We have these wrappers for all the other languages like Clojure as OM and other things as well. So it's quite common to use the existing JavaScript libraries and then build on top of those. With the Scala.js React, you get type safety on top of React. You can get support for functional programming libraries, so you can use your state monad there. You can use lenses and so on to make things work smoothly. And it also comes with its own custom router and utilities, so you can get started right away instead of having like 12 different dependencies to start developing your application. Here's a typical example of what writing a render function in Scala.js React looks like. You just have these HTML tags Everything is type safe, and so it's quite easy to get things up and running. But so I was using Scala.js React for quite a long time, but I sort of felt that okay, it's not really taking things far enough. I mean, React is after all, it's a simple library. It's a Vue library doing a very limited thing. So I decided that I'm going to start my own project, Suzaku, which I did about a year ago. Now, Suzaku is a mobile-first application framework for web. It's written entirely in Scala. It doesn't require any JavaScript libraries underneath. And it has a very straightforward value proposition. So Suzaku helps developers create beautiful, functional, and efficient applications for mobile and desktop web. It's easy and fun and safe to use, and lets developer work purely in Scala. Whether that's a good thing or a bad thing, that depends on the audience. Before we dive into what Suzaku is and how it works, let's talk about performance. So performance is, of course, critical for all applications out there, and front-end applications are no exception. If you look at the web, you can find these benchmarks with comparing different libraries. How long does it take to insert 1,000 lines into a table, or modify every 10th entry in the table, and all these things that you can compare that, okay, which one is the fastest? And there's a lot of libraries. This is showing like less than half of libraries benchmarked here. So there's a lot of choice out there. But a lot of these benchmarks are pretty meaningless, because this is not really the performance that matters, that how long does it take to insert 10,000 lines into a table. Nobody does that in a real application. What matters is UPP, which stands for user perceived performance. So user perceived performance has a lot of meanings. It can mean that you use animations and things like that so that people don't feel like they're waiting. But it also goes deeper into the architecture of the application itself. That how can you remove those yanks? How can you make sure that everything runs at 60 frames per second? A lot of frameworks don't really address this in any way. I think one of the first ones is React Fiber. It's still in beta, so not released. But Fiber is a version, it's like a rewrite of React that Facebook had a team working over like 2 years. So it's a pretty complex thing. And in React, what takes time is basically comparing the old and the new. It uses a virtual DOM. So you describe that what you want, and then it compares that, okay, what has changed, and then applies those changes to a real DOM. This process is called reconciliation, and it typically can take quite a lot of time depending on the complexity of the UI. So in Fiber, they are basically breaking this reconciliation process into these smaller chunks that they can then prioritize these updates, that if you have an animation running, you want to prioritize that over something that's, let's say, happening off screen, that nobody cares what's happening off screen, but you want those animations to be smooth. And it can also schedule these chunks so that if you have a large update, you can break it down into these small chunks and then schedule them over time. So not everything happens in a single frame, but it sort of gradually does those updates so that things keep running smoothly. And this is, of course, to sort of sidestep the limitations of JavaScript and single thread and all that stuff. But it ends up quite complicated, especially since you have to be compatible with the old version. In Suzaku, we take a bit different approach. So we all know that mobile devices and desktops now have multiple cores. They might not be so fast cores, but there are more than one. But in the web context, you can typically use only a single core because JavaScript is running in a single thread. In Suzaku, we are actually running the UI and the application in 2 different cores, which immediately gives the benefit that the UI is not limited by what's happening in the application code. So the UI keeps running at 60 frames per second, regardless of how complicated things you are doing in the application. There are also some other benefits to this separation, but let's go to those a bit later. The same approach can be extended, that we can use even more cores if there are some long-running tasks in the background. Now in the web, we don't have threads. We have what's known as web workers. They are a bit like threads, but more like separate processes. They don't share memory. So the only thing that we can do is basically send messages back and forth between these web workers. In Suzaku, we are serializing Scala objects into a binary format to make the message passing very efficient. And basically, we are just sending back and forth messages, updating a UI, getting interaction events back from the UI, and keeping those things in sync. Of course, doing this kind of serialization is not free. There's a cost, but it's offset by the benefit of using multiple cores by a pretty wide margin, especially considering the user perceived performance. To make things a bit easier to use this kind of communication, we use a type-safe virtual channel system built on the Arteria library, also part of the Suzaku framework. Basically, it hides the underneath plumbing that how our message is actually built and sent between the web workers and things like that. So the application only sees these virtual channels where the application can push messages and receive messages, and those messages are type safe, so you cannot send wrong kinds of messages. In practice, every UI widget has a representative proxy on the application side, and these two are communicating that if you have a button and you update the button state, then a message is sent to the UI. If you click the button, then a message is sent from the UI to the application to update your application state and so on. So there's a very clear division of labor in Suzaku. In the UI, you do things like interaction, rendering, animations, transitions, and expansion of things like drop-down menus and so on. So all those things that are not really like application stuff, that it's nice to have, it might be necessary to have these things, but you don't want like animations in your application code. It just makes the code messy. Instead, on the application side, you are just worried about your data model, what kind of presentation you have there, how to do navigation between different views, how to validate the user inputs and so on, how to do communication to the server side. In quite often, you can actually end up in a situation that if you have multiple applications, they can share the same UI code, because the UI code doesn't really contain any application-specific code. It can be like a separate module that just contains all the widgets that you are using. You can compile it once, and then you just keep compiling your application code and communicate with the UI. Now, another benefit of having this kind of a strict protocol between these two is that we can go multi-platform. The application itself doesn't really know what's the UI. It's just a protocol. Button is a button, whether it's web or an Android button. So you can, in theory, use the same application code for different platforms. Of course, in practice, you have to consider these things, but a lot of the application code can be shared. So this is a bit similar approach that you get with React Native, where you can also do things like cross-platform development, except that React Native and the React Web are not really compatible, because the other one is purely on the DOM and the other one is using native components, unlike Suzaku. One benefit of the Suzaku approach is that you don't need to have like a JavaScript virtual machine inside your application. You can actually compile your application into regular Scala JVM code on the Android, or if you're using iOS, you can use Scala native when it gets to the point that you can actually do iOS development. It's still very early on. But basically, you can do native applications with Scala as well. Or if you're doing like Electron-style desktop applications, you could have the UI running in a Chrome setup and then have the application code in JVM or native. From a programmer point of view, Suzaku looks very similar to React. You have the render method where you describe that what you want the UI to be containing. So it's a very functional, declarative way of describing your UI. You're using components and widgets. The difference is that the components reside in the application side, and the widgets are something that actually exists on the UI side. So you just describe, just like in React, okay, this is what I want the UI to look like. If some changes happen, then Suzaku will apply those changes on on a component or on a widget by widget basis. So let's say the reconciliation algorithm in Suzaku it doesn't need to deal with the DOM or virtual DOM. It deals with a higher level abstraction, making it faster and more efficient. All in all, Suzaku aims to have a very holistic approach. So the rendering is pure functional, making it easy and understandable. But it also has these high level UI widgets, so you don't need to deal with HTML divs and so on. And you can use high level layouts using grid and flex and so on, making the application developer a lot easier. It also has a very consistent code-driven styling. So instead of writing a separate CSS, we all know, or at least all of us who've been doing front-end programming, that CSS is like a single global namespace, and it's very difficult to keep it modular. But with Suzaku, you are actually doing the styling in the code, and it just generates the CSS as it goes. It's been built to support mobile and desktop from the get-go. So most of the views, most of the stuff you do in your application can be shared between mobile and desktop, and you can then define these divergency points where things get different for mobile and desktop. It will have support for animation, internationalization, and localization, so you don't have to use other libraries. Most of these things are going to be like separate libraries within Suzaku, so you can replace them with something else or you can extend them. But the whole idea is that it's kind of a like holistic thing that you can just start using and get productive very quickly. It also comes with a functional application state management library called Diode, which works pretty similar to what you have in Elm or in OM for ClojureScript or in Redux for React. So basically you have this single immutable model that represents the state of your application. The only way to update the model is by dispatching these kind of actions, and the actions are then managed by the circuit. And when changes happen, the circuit can notify views, and the views can go and read the updated model. And if there are like user interactions, then the views are dispatching new actions, and this keeps going on. In addition, there is a effect system to handle those nasty side effects, like calling a server for new data, so it doesn't confuse the system itself, but every effect then creates another action that then updates the data. And this also helps in like testing, because you can just ignore the effects. You can just skip all the calls to the server when you are doing testing. So a couple of quick code examples how the models are defined. This is from the to-do MVC example coming with Diode. So you just define the application model, which is like a list of to-dos using these case classes. Basically, the application model is like a tree of things. And then you define the actions that are then targeting this model, that what you want to do, if you want to add a to-do, if you want to update an existing to-do, delete, and so on. Then on the view side, you get access to that model. You can render these individual to-dos. And then when you want to do something with those to-dos, then you dispatch these actions. Like if you want to delete the to-do when the user clicks an X button, then you just dispatch the appropriate action. So there's no need to have like action builders or some of the other boilerplate you get from Redux. It's all pretty straightforward and type safe using case classes. So within the circuit, then you define these handlers for your actions, what you want to do when you receive an action. And this handler doesn't really care about the application model as a whole. It just sees very small part. It's like using a lens. This model RW is pretty much like a lens. It just sees that sequence of to-dos. And then when you get to add a new to-do, it just updates that sequence, and then the Diode framework sort of takes care of updating the actual application model. So in short, Suzaku is a functional UI framework. It's probably not as functional as you would get in Haskell or Clojure, but it's from the user point of view, it's quite functional. The focus is on practical developer experience. So it doesn't have like a strong ideology of some kind of purity in things that, okay, I want to do these things exactly like this. It's all about minimizing the hassle, improving the productivity of the developer, and providing all the tools and libraries that the developer actually needs. It has a relatively high abstraction compared to the other libraries out there, but even with this high abstraction, it also offers high performance, especially considering the user perceived performance via using those multiple cores. And it supports cross-platform, let's say eventually. It doesn't right now, but the architecture has been designed from the beginning so that it can be used in a cross-platform situation. And of course, it's 100% Scala, so you don't need to deal with JavaScript, HTML, CSS. But if you want to, you can use them. You can use JavaScript libraries on the UI side. You can write HTML on the UI side. You can do CSS stuff over on the UI side. But none of this is sort of touching your application code, so your application code stays cross-platform. And there are no patents or license issues, as there might be with some other libraries out there. So it's still a bit experimental. You can get contributor access by going to the repo. It contains the most up-to-date version all the time. I'm aiming to get a beta release out this month. I've been pushing this number up every time I'm giving this kind of presentation. It used to be Q1 last November, but it didn't quite make it there. All right, that's all I have. Thank you. You can reach out to me on Twitter or on GitHub. And if you are a Finnish developer, I highly recommend joining our Koodiklinikka Slack. There are over 1,000 developers out there. It's a very active Slack. We sometimes even talk about coding there. And of course, my company Umbra, we are hiring. So go check out those jobs. So thank you.
All right, thanks Otto. We have time of one question only, if there are any. If there are, yeah, one.
Okay, thanks Otto for the great talk, but could you tell something about the developer experience with Scala.js, the tooling and the workflow, stuff like that?
Right, so you are using the same tooling as with Scala, so SBT. Everybody loves SBT. And let's say the round trip time from editing to compiling to running code is relatively short. So the compiler is incremental. So typically when you're doing small changes, it's just a few seconds. For example, if you're using Scala Fiddle, it actually compiles on the server. So it sends the code to the server and compiles. And that whole thing typically takes less than 300 milliseconds. So for small things, it's relatively fast. If you're using complex libraries like Shapeless, then the compilation times, of course, go up. But typically, reloading, compiling, all this stuff works really nicely, so you don't have to worry about it. In many cases, it's actually faster than JavaScript if you're using Babel and these other tools that make the compilation cycle over there quite slow.
Thanks.
All right.
All right, thanks Otto.
Thank you.